Well, there's lots of notes. Good morning, everyone. I'm going to do this in language, so let me get the technology to work. Yamandu Marang, Yuandu, Marg Macmillan, Wiradjuri, Gabir Trangi. Injamarabu, Wurundjeri, Nurumbang, Kulan Nurumbanga. Daga, Nyaninya, Nangida, Nadu Mandang, Nyanigu Widden. Girialana, Bangamalana Bu, Naniyang, Mawangalang, Injamara Nija. So, are you good? And how cool is this day? I am so excited to go, what you produce from your brain that will affect us as human beings is an extraordinary honour for me to be here, but also to say welcome and acknowledge the Wurundjeri people of the Kulin Nation. And as we produce excitedly new knowledge, how do we maintain that excitement of where we're producing it, how we're producing it, and its application? So not only do we acknowledge the Wurundjeri people of the Kulin Nation on whose lands we meet today, but on whose lands we are producing new knowledge that is for the benefit of us all. And how do we pay respect to that shared place of where our knowledges meet and how we start to innovate around those knowledges, like I said, that is good for not just you as inventors, you as knowledge producers, but how do we respect, rightfully, how and when you produce that knowledge, it benefits Kulin. It benefits us all, but most importantly, it benefits the relationship of reconciliation. So that's my job, because I've got to hand back to Maggie. This is precision. I am from the social sciences, so this precision is something new for me. Enjoy your day, but I look forward to actually being able to hear what you have been doing. So thanks, Maggie.
Thank you. Thank you very much, Mark. Thank you for your inspiring opening today. Good morning, ladies and gentlemen. A warm welcome to all of you to the inaugural RMIT University Redback Innovation Challenge. Thank you all for coming and joining us today. And our Vice Chancellor, Martin Bean, is also among us. We all know how busy you are. Thank you for being with us. My name is Maggie Zai, and I am your MC this morning. For those of you who don't know me, I spent the last 2 years as a research fellow in the School of Science, but recently I was seconded to the Research Innovation and Entrepreneurship team and became someone to support our research community. So as part of the team, I have been witnessing some of the great activities around this Redback Innovation Challenge since day one. So I'm very excited to be here. The 2017 Redback Innovation Challenge is a pilot program for strategic innovation, developed in conjunction with the Enabling Capabilities platforms. We aim to connect postgraduate students, undergraduate students, and graduate researchers to build interdisciplinary teams to develop their skills and to create impact through research and innovation. So the whole journey starts almost a month ago. We have brought together more than 30 graduate researchers, postgraduate students, and a couple of undergraduate students. As you can see up there, they're from 9 different schools across RMIT, and they have been mixed and formed into 6 teams. Remarkable interdisciplinary diversity, I'm sure you all agree with me. So together with their innovation facilitator, Stephanie Tu, they have been working very hard on their challenge over 3 rounds of innovation sprints. The challenge we gave them this year is using artificial intelligence to solve some of the biggest problems in Australia, such as energy, underemployment, and health. So today is going to be the peak of their journey, and we're going to hear them pitching their ideas in front of us. But before we get on to that, let's talk about artificial intelligence for a minute. What does AI really mean? Well, to answer that, let me invite one of RMIT's AI leading experts, Associate Professor John Tangaraja, to talk to us about his view on AI. Let's welcome him.
Thanks, Maggie. So I'm John Tangaraja, and my expertise is in artificial intelligence, and I'm here to share my view of artificial intelligence in just 2 minutes. So let's start with the definition. So there's many definitions out there. One that I like particularly well is one by the late Marvin Minsky, who pioneered AI from way back in the 60s. He said, AI is the science of making machines do things that would require intelligence if done by men. So it's a science of doing with intelligence. But what's intelligence then? From my point of view, intelligence is like beauty. It's in the eye of the beholder. It's perceived. So if I asked you, who's cuter, the pug or the Labrador, I'll get different opinions from you. But let's move to machines then, and what makes us perceive machines to be intelligent. I'll give you a blue robot and a red robot. I put them in 2 different rooms and I give them each a red ball. I observe them, and let's say the blue robot stands there, doesn't seem to realize there's a ball in front of it, doesn't do any interaction, just walks around, doesn't do much. You'd say that's not very intelligent. In the other room, the red robot sees the ball, observes it, walks towards the ball, starts interacting with the ball, and over time learns to play soccer with the ball. You say, hey, that's a pretty intelligent robot. Let's break that down and see, why do we think, what's it doing, and why do we see it as intelligent? So the first thing it does is observes. It observes its environment, looks around it, hey, there's a red object, it might be a ball. Then it does some deliberation. What do? There's a red ball. Maybe I walk towards it. Then it does an action, walking towards the ball. It observes again, it deliberates, and it acts. This is what we do in everything that we do. We observe, we deliberate, and we act. But what makes it intelligent then? So in my view, this deliberation needs to be rational, in that if I'm a soccer playing robot, I have an open goal. If I kick forward, I score. It doesn't make sense to turn around and kick the other way, right? That wouldn't be rational, that wouldn't be intelligent. In addition, intelligent machines need to be able to learn. If I do the same behavior over a period of time, I need to get better. Or in the case of my red robot that interact with the ball and learn to kick, you should be able to learn new behaviors as well over time. So learning is another key component of intelligence. And finally, when we have multiple robots or multiple machines, they need to be social, in that they need to interact with each other, collaborate, and in some instances, even compete. So the ability to be social, learn, and make rational decisions on top of the basic behaviors is, in my view, what makes things artificial intelligence. I will end by saying that I see a very bright future for AI, and AI is going to be an integral part of every single piece of future technology. And hey, there are teams out here who's going to pitch multidisciplinary projects with a focus on AI, and that's just great. I wish you all the very best, and thank you.
Thank you, John. That was really cool. I now have a much better understanding of AI. I do have a couple of questions regarding the blue robots, though. What if he's just standing there and thinking? What if the blue robot is a philosopher? So we'll discuss that. We'll discuss that off stage. Thank you, John. And you know, the wonderful thing is John, and together with two other AI experts from RMIT, also spent a couple of afternoons with our participants during their sprints. What were they doing? Well, let's take a look.
Part about the challenge is that I get to work with students from different schools, so School of Management, School of Science, School of Business, a lot of different schools, and it brings a lot of different interactions and ideas into a problem that I could not have solved by myself.
It's like really about stepping out of that comfort zone that you're set in when you're in that one place and just being there and enjoying it.
What an incredible journey. Yay! I wish I could have been part of it. But now you get to play a part in it. I believe you all received a token when you came in today? Yes? Yes. Now you may already have found out that they are not the Lynch chocolate tokens, unfortunately, but they are actually for you to vote for your favorite team. And the team who wins the most tokens today will get the People's Choice Award, which means that they'll get invited to participate in the next seed funding round. So it is a really good opportunity for them, and please hold on to your tokens until the end of our session today. Now, without further ado, let's welcome our first team, Team E-Thinkers.
Good morning, everybody. I'd like to introduce our team. We are E-Thinkers, Faisal from Management Department, Gianni, Daniel, and me, Pune from Engineering Department. The name of our idea is IntelliFridge. We want to use artificial intelligence in the field of edible food waste management. We plan to kick off this project first at RMIT and then expand it later on. We have estimated that there are more than 1,000 catering events at RMIT per year, and there is always leftover food. To manage the edible leftover food, we come up with this idea, IntelliFridge.
Wow, IntelliFridge sounds great, isn't it? But you guys must be wondering, why do we need to solve this problem? Why IntelliFridge? Because food and agriculture, these are finite resources. But what we don't realize that these resources are so precious. If not for us, then for the people, those who are in the street, for the people, those who are homeless, and for the people, those who are fighting against hunger. And guess what? These people are not low in number by any chance. There are approximately 2 million Australians, those who are relying, dependent on the food relief. And charities, those who distribute this food, they say that nearly 90% of the time they have no food. But we do have food, but we are not doing any justice with our food. What we're actually doing, we're actually wasting food of $8 billion per annum as a nation. No wonder this rate has increased by 6% in the last 3 years. So it's not a problem anymore. It has become a crisis. If not addressed promptly, it may get even difficult to manage. Over to Gianni.
Thank you, Faisal. So our project solution for this obviously is IntelliFridge, and it works on two fronts. So there's an actual physical aspect, so a fridge that'll be located at RMIT, and a second aspect, which is the app, which assists with logging produce and stock and allocating it to certain charities. So how it works is, so if you have some food that you're concerned that you're not going to use it, and so you don't really want to throw it out, you log it with the app, then go to the fridge, and then place it in a biometric scanner. You can see here the way that the scanner works is it actually it monitors the stock and makes sure that it's good to go. If it's not, it does not accept it and will be placed in a receptacle afterwards. So once it passes the test and is logged in the fridge, the donor walks away and goes about their business. A charity will then log on to the app, investigate, see what the stock is inside the fridge, and make certain recommendations as to what they should be using. From there, they then withdraw that and then go about their day. Now we use the app so we can make sure what's in the fridge and managing, to make sure that companies themselves don't double book or make sure that every allocated stock is accounted for. Now, in the event that some produce is not used, there are certain sensors that will be installed into the fridge that will assist in detecting gases that are produced through a breakdown procedure. Now, the role AI plays in this will be varying from, depending on the phase of our development. Initially, it'll be in managing the stock itself and make sure that the food is all okay. And then from there on, it will then be passed on to, hopefully, in predicting what our most likely income is to assist people in planning around, the charities planning around meals involving that food. So something like this has not been done before. Most of the technology actually already exists already. It's quite prominent, but it's just a matter of putting it all together and getting it all going. I'll just pass it on to Daniel now.
Well, thanks, Gianni. I'll be telling you about the conclusion we are making with this idea. So we are trying to build a bridge between two ends, the people with the excessive food and the people who doesn't have food with this idea. So we are also hoping that we'll get the sponsor such as any corporate giant to their CSR. Maybe it could be RMIT that can help us to finance this project. That's pretty much, but before that, before doing the assumption, we'd like to conduct research in the market to see how people and public react to this facility. And if we can add up anything, if we find anything that we can add up to make an even better version, that we can do it before the final design. If you have any query, any comment, anything that you want us to explain to you, you can simply write us to our email address, eat.thinkisforfood@gmail.com, or you can simply come to us and we'll love to explain it further to you. That's all from us. Thank you so much. Thank you, Steph, for helping us out, and thank you. It's an honor to present this live here.
Great job, Team E-Thinkers. And I wonder when the IntelliFridge will come out, but just for now, I have every confidence in our Team E-Thinkers to take good care of our leftovers from morning tea today. Let's welcome our next team, Team Leap.
So if cars can now think and drive themselves, how about buildings?
Well, the thing is, buildings can think for themselves, but the problem is how they think is quite limited. So we've developed an AI solution to make buildings more energy efficient while enhancing customer experience, and we'd like to pitch that to RMIT, the Vice-Chancellor and guests today. Thank you, Javier.
Hello, everybody. We are Team Leap. We're a collective of postgraduate students here at RMIT with a combined skill set on engineering, producing, programming, communication, and design.
Thanks.
And we're here to introduce you to our new project, the Building Brain.
Thanks, Javier. So to tell us more about Building Brain, Charlotte and Dook, could you explain what Building Brain is and how it might work for RMIT?
Sure. So smart and centralized buildings, they are everywhere nowadays. The system can actually turn on and off the light, cooling, and also heating system at certain times. But these smart buildings can only do what we tell them to do. So in fact, it is not really responding to the dynamics of the environment. For example, I remember the other day Javier told me that he went to a class in building 45 in the evening at about 6 o'clock. All the lightings and heating system just turn off by itself, even though there are still classes running in there. So this is because the system has been programmed in such a way. The limitation of its inflexibility can definitely bring a lot of potential for improvement.
I can see the limitations there. Could you explain to us how Building Brain is different and how it thinks for itself?
Yes, MMA. So we want to make the smart building become an intelligent building. We understand that different buildings have different purpose and different customer. The hospital is very different from us. This building is very different from us. So what do I mean by intelligent? An intelligent building must be aware of its own power consumption and about its customer requirement. Secondly, this intelligent building must continuously gathering data, learn from them, and get better. The third one is the intelligent building must be able to respond to the environment, changing in the number of occupation, changing in the weather outside, any type of change.
I can hear how Building Brain is going to be responsive for different organisations. Can you give us a RMIT specific example?
Yes, of course. We can all remember last week we had a public holiday for the grand final on Friday, right? Actually, a lot of students from the Friday class, they don't want to miss out the class, they join the Thursday class. So the room get more crowded. A lot of my students, my friends complain about that because the temperature is rising, too many people. If we have our intelligent building, the building can predict something like that happen and respond earlier. Even something happen, our building cannot predict because it's intelligent, it will respond still faster. So this will get our user more comfort while still minimum the power consumption.
Thanks, Dirk. I can see how it will be a really dynamic system. I heard you mention data. Paul, could you tell us a little bit about the data that might already be available at RMIT that could help Building Brain adapt?
Certainly, data is actually the fuel behind our Building Brain. And right now, the data is actually in three categories. There's environmental data, there's data about the building environment itself, and also data about the occupancy. So, and the best news about this is that this data is already there, available, and we are not making use of it.
So I heard you talking about environmental data. I suppose that would be about temperature, about light, about the how hot and cold it is, etc. But if I think about it, I also think about our learning management system, Canvas, which might also have a lot of data in there about how many people are in class, what buildings are being used, etc. And that sounds like that would be useful as well.
Certainly, it will be.
Great. So if I were an organisation, hopefully like RMIT, Natalia, can you explain to me what the process might be if I want to take on Building Brain?
Okay, so the first phase is we'll come in and we'll consult with you to determine your energy requirements. The second stage, we'll look at the data within the organisation and we'll also gather more data that we need. The third stage, we'll install Building Brain into RMIT or other organisations like it. And that means that there'll be comfort, you'll save money and improve your energy efficiency.
Thank you. Well, as Deputy Vice-Chancellor and Vice President of Research and Innovation, Callum Drummond said the other day, RMIT prizes innovation and entrepreneurship, so we're hoping that you'll take on our idea of Building Brain. Thank you for listening to us and perhaps there's potential in the future for a city brain.
Thank you very much, Team LEAP. Another great pitch. I'm sure you all agree with me. Let's welcome our next presenting team, Team Prosper.
So they say it takes a village to raise a child, but what about an office? Hi, we're Team Prosper. I'm Beck from Architecture and Design. I'm here with Marissa from Media and Communications, Adam from Science, James from Business, and Bilal from Mechanical Engineering. We're here to share our idea for an artificial intelligence application called It Takes an Office. because it can and should take the whole office to help a mother raise a child and come back to work in a meaningful way.
Hey guys, so I'm going to discuss the problem with you. So basically, we've decided to look at gender-based underemployment because we found that 90% of women hold the casual or part-time roles in Australia. That's a large amount of women. And 50% of those women have reported having a low subjective sense of purpose in their workplace. So why should a woman's biological need to take time off for maternity leave interrupt her career path? Hence why we've decided to investigate the possibility of using artificial intelligence to create a linear career path so that when she leaves from work and comes back, it'll be as if she never left and her career progression stays the exact same.
So we here at Prosper understand the career changes and difficulties that she goes through when she's on maternity leave. And this is why we have generated an artificially intelligent integrated platform which allows easy transition to move through and also is very accessible on mobile phone and on computer as well. It creates a linear career path for the woman to get through and also allows her to interact whilst maintaining the company's ability to create workplace relationships which are meaningful. The woman can easily access the application on phone and computer and lock her information on there, and this allows her to keep contact with the ongoings of the workplace even when she's not there. Now, this is a very integral part of the application because knowing what's happening within the company whilst she's not there allows her to have a sense of self and ability to really connect with a company that she might be missing. So key dates like milestones and training programs and different things like that, and also maintaining that dialogue with upper management and her co-workers is very important. This will allow the all-encompassing feeling of community and will also help her transition easily back into the workplace for meaningful work whilst also feeling like she's never left.
Our AI is a value-based matching system replacing traditional matching of roles and job titles. Our AI uses a merit-based matching algorithm. It interprets semantic meaning from the inputs and assigning them a merit. Inputs from the work site, such as meetings, projects, areas of interest, determines the merits required. Colleagues put in their areas of cooperation and collaboration. Mum puts in her values and skills, and the application matches these qualities to determine a merit-based relationships to give value purpose-based employment.
Awesome. So I'm just going to quickly walk you all through an example. So if I was taking time off from work for maternity leave, my employer, my boss, my team, and I would use this application on our desktops, on our phones, and we would log all of our value-based tasks and responsibilities. I would put in things that I found most useful, most important, meetings, milestones, all of the above. And when I came back from work, when I onboarded back from my maternity leave, not only would my employers place me into roles that they found useful, but the intelligent application would match my values and skills from before I left and the things that I found most useful into the new roles and responsibilities after my year. So basically, the whole point of it would be, once we came back on, I would be a part of the onboarding process.
By providing the AI application to mothers and industrials, we will achieve not just unbreaking the break, but also giving them a purposeful work once they return from the maternity leave. Wouldn't it be great if we develop that application for another marginalized groups who need to be away from their workplace for a while and for some reason? For example, the ones who get injured and feel being underemployment once they come back. To move forward, we will be determining the functions, boundaries of the application, then we will be prototyping of the application, then testing them with the real users in order to provide them the best user experience.
It takes an office to raise a child, and with our AI application, we hope yours can be the one to unbreak the break. If you agree, remember the name Team Prosper when you're voting this morning. Thanks for listening to us.
Well done, Team Prosper. You know, last Monday's Q&A on ABC TV, I was watching it, and the topic was also on artificial intelligence. And there are many questions from the audience, which is about the anxiety and, or rather fear around how artificial intelligent robots taking over humans' jobs. So I'm really glad to see our team Prosper is using artificial intelligence in a very positive way to support our career and our workplace. Let's move on. Next presenting team, let's welcome Team Shark.
Good morning, everyone. I'm Cecilia from the School of Economics, Finance and Marketing.
Good morning, everyone. My name is Jharna, and I'm doing my PhD from our Global Urban and Social Studies.
I'm Sultan from the Center for Advanced Materials and Industrial Chemistry, School of Applied Sciences.
And I'm Prashant from the School of Engineering, currently pursuing my PhD.
Right. Now, we bring our diversity as well as our experience and our expertise together to present Breath IBTs, a non-intrusive, portable handheld device with AI-driven system that uses patients' breath to monitor blood glucose level, which can be used anywhere, anytime. Diabetes has already been recognized as the fastest growing chronic conditions that leads to stroke, heart attacks, kidney failure, as well as blindness. A CSIRO report shows that 1 person in every 5 minutes develops diabetes in Australia. And the problem is even worse in very remote area where the rate of mortality is 2 to 4 times higher than Australia's major cities.
As Cecilia mentioned, problem is quite serious here. As Australian Bureau of Statistics data shows that diabetes is the second leading cause of death among Indigenous Australians, and they are 3.6 times more likely to have diabetes and twice is likely to have newly diagnosed diabetes in compared to other Australian citizens. So as we all know that dealing with the health of Indigenous Australians have become a very big challenge for Australia.
Now, the typical way for any patient to diagnose diabetes is to prick their finger and draw blood. But as you know, that this means that the patient has to get used to the pain, and you have the cost of lancets and the test strips. And you also have the problem of availability in remote areas. In a perfect world, diabetes monitoring should be painless and should not cost as much as it does right now. So how is it possible?
Non-invasive self-diagnosis. Interesting. How is that possible without blood samples from our human breath? Human breath is the most complicated gas ever. It has more than 200 gases in it. When someone develops certain disease, certain gases are found in abnormal proportion. For example, someone develops diabetes, acetone is found in excess concentration. We have developed a new type of sensor which can accurately sense your acetone concentration from your breath relating to your diabetic condition. For example, if the acetone concentration is low in your breath, your glucose level is low in your blood. Vice versa. The most important thing of this device, it is portable, no more hand pricking, painful blood samples. You don't need a doctor, you don't need lab setups, and the most important thing, it can tell your diabetic condition in less than 3 seconds.
As Sultan mentioned, the functions of the device and how how an individual can use the device. So it's very simple to use. The device that we plan to develop can be connected to mobile phone easily, and launch an app, trigger the measurements, blow into the device and wait for it to pass the measurement, and one person can wait, check the result, and app will also make the recommendation if needed. The person can see the doctor or visit the nearest healthcare center.
And this is where AI comes in, not just providing a raw blood glucose value, but correlating that value with the person's age, gender, weight, and location, and other features. So the AI would then be trained offline, not on the device, but then the results would be passed on to the device, and we will also be continuously improving the performance of our algorithm using the data that we obtain.
Great. Now, our metric of success would be achieving an increase in early detections of diabetes in remote communities in Australia and reducing the cost of monitoring existing diabetics. A key assumption here, of course, is that the patient would be willing to actually share the medical information with us, as well as use the device regularly. A very first step we would like to do is to test our assumptions and do a survey amongst doctors as well as patients in healthcare centers and pharmacies.
Ladies and gentlemen, let's jump 1,000 miles further and provide the indigenous Australians with this device to identify their diabetic conditions by themselves. Thank you so much for joining us today, and it's a pleasure sharing this novel thought. Thank you.
Thank you, Team Chuck. That was a really good idea, and I hope you can have opportunity to bring your idea to life. Up next, our next presenting team is Team Transformers.
Good morning, everyone. We are Transformers presenting making privacy in surveillance, not a trade-off. My name is Alif Takhar Chaudhary. I am a PhD candidate in School of Management.
Yeah, my name is Long. I'm from School of Engineering.
Hi, my name is Terence, and I'm from the School of Architecture and Design.
My name is Diaz. I'm from the School of Sound. I'm Hamdullah, and I study at GUS.
And my name is Yamam. I'm doing my PhD on mental health. But I'm not here to speak to you about mental health, although it's something very important. I'm here to talk to you about privacy. So, how many times have you used social media? Facebook? Instagram? So every time I go there looking for something for my kids, like tennis activities or a dress, this is what I see on my Facebook page. And I feel that I'm watched. Do you feel this way, guys? Yeah. So privacy is everyone's concern, and it's not a trade-off.
As your mom told that privacy is everyone's concern. So why not to develop a privacy stars rating system? We are health conscious, so we have developed health stars rating system. We go to Kohl's, Aldi or Woolworths, and we look for the stars for edible things. If there are 5, we buy. If there are 3, we leave. The same way we are energy conscious, so we look for the appliances, electric appliances, which are more energy efficient. So the same way we want to develop, and we are going to develop, an artificial intelligence system which is going to give us privacy stars rating. And this artificial intelligence system will not only observe, will observe, deliberate, and will not merely act. It will feel like you and me when the privacy is breached.
Okay, from this idea, we run the project. And then we have our product we call XBL. It stands for the Human Privacy Collection. And then we took 3 potential customers. The first one is the government, the second is the app makers, and the third one is the businessman. And then our product, we have 2 important functions. The first function is the government use our apps to install in the electronic device, and then can give for the new apps the license. And the second one is our app can do the statistics to rate for the new apps. That's all. And next one.
So what makes this concept or idea unique? This is the first time AI is used in this context for its ability to detect and filter potential threats. This is done without breaching individual privacy. And the AI collects customer feedback and observes the activities of the other apps. And it deliberates and ultimately uses the information to determine the star rating that was being discussed by Hamdullah.
Thanks, Darren. So how is it going to make our concept successful? So according to Maslow hierarchy, we have 5 human needs, 5 basic human needs, and safety is one of them. So
So who are our customer? The government, the business center, and the user, right? So the number of threats can be detected, might be useful for the customer and the business center, and the number of application can be downloaded, might be useful for the user, and the rate of the satisfaction from the customer is also the key factor for success for us.
Thank you. So privacy is basically everyone's need, and it is a dilemma in this digital era. Everyone is looking for, like, they are watching us and they want to know anything they can about us, and we want to share what we need to share with them. So actually, making the idea of this app is this: we need to provide a software like thing for individuals who can protect their privacy thing. Like, you know that when you try to download some social app or anything on a web page, they will give you some privacy thing, and you need to check that, you need to click on that, otherwise you won't use that app or that web page, like these things. So we want to provide such a rating system which will provide the privacy ratings to those apps, and those apps must be concerned for their privacy things, so they shouldn't breach your individual privacy, and you need to aware how much they are taking your data. So this is our today's presentation all about, and I think, and I'm concerned about my privacy, and I think you may be concerned about your privacies as well. So you need to vote us for that as well if you want it to be in a real mode. Thank you.
Thank you. Thank you, Team Transformers. Very well done. Please do let us know when the privacy star rating comes out. All right, our lucky last. Please welcome our last presenting team today, T2.
Hello everyone, and thank you Mr. Prime Minister for hosting us here today at the Renewable Energy Summit. We are here, me, Arif, Fiona, Tibra, Mujda, and Taylor from the think tank T2. Unfortunately, Taylor is not here because he is at New Space Station. We are here to unveil our policy reform plan that will revolutionize the electric grid market.
It is the year 2030. We have achieved 60% of renewable energy, putting us on track for a target of 100% by 2050. The main drivers of this have been the completion of the Great Dividing Range wind project and the rise of rooftop solar arrays by homeowners, aka voters, since the price of production has fallen. This leads to the hot button problem of renewable energy intermittency. Renewable energy is now the main energy source. With this comes the added problem of predicting energy production, which is currently poorly done. So the Australian Chamber of Commerce recently released a report stating that if reliability in the energy grid is not improved, gross domestic product will fall by $2 billion by 2040. $2 billion. To avoid this, the current policy is to build excess of renewable energy-based power stations. Although this will theoretically avert the issues of intermittency, it will come at an excessively large cost to the taxpayer. And we know how important taxpayers are, Mr. Prime Minister. There are also issues of the pricing of electricity and the transparency of the market. Electrical companies are currently charging peak prices on power when supply is low rather than when demand is high, like the old days. We believe we can help with this solution to reduce the need for as many energy-based power stations without jeopardizing the energy system and bringing greater transparency to the production of energy.
Leading to the solution, Mr. President, we are presenting SEG, Smart Electrical Grid. Our SLEG will revolutionize the conventional electrical grid, we believe, because it acquires data from all over satellites for weather data, and it's integrated with the renewable energy source data, and it predicts the best price. So at first, AI-supported SEG can predict accurate renewable energy production capacity in a locality, which allow better prediction in unit price. That also allow our industry to plan accordingly when the energy supplies is higher, so that they can provide cheaper price. Next, that matches the supply and demand. So this way we can better match supply and demand with the help of SEG. And finally, we can offset our capital cost, which shown in the next bar chart below. So with SEG, we can eventually reduce our capital cost.
In this slide, we are going to state how we get there. Before the national rollout of the SEG, we just suggest the pilot study is conducted in Western Australia, as it is not connected to the grid in the eastern seaboard states. So it will be the best and perfect location to test SEG. Two objectives of this trial would be to first prove that SEG can actually and reliably predict the energy production potential of a given locality, and secondly, determine that if the energy providers actually can change their pricing structure, and also the local industries can change their behavior of the usage of the energy.
Once again, we would like to thank you, Mr. Prime Minister, for inviting us at the Renewable Energy Summit and lending us your priceless time. We hope that we have convinced you that smart electric grid systems should be implemented, as it will reduce the overall cost of reaching our target of 100% renewables by 2050. Thank you.
Thank you, Team T2. And congratulations to all our teams today. You've done a wonderful job. Woo! And let's not forget that these guys only met each other 3 weeks ago. So great achievement. And now, I would like to introduce someone I've known for the past 5 years, who I've learned a lot from during my postdoc fellowship in his lab, and who I believe is among the most supportive and inspiring mentors to the young researchers. Please welcome Professor Callum Drummond, the Deputy Vice Chancellor, Research and Innovation, and Vice President.
Thank you, Maggie. And I should say, as the Vice-Chancellor is leaving the room, he's got to chair a meeting at 10:30. He did want to pass on that he thought this was absolutely awesome. And like me, he was just totally inspired and overawed by the contributions from all the participants. I mean, how fantastic was that? What a wonderful job all the participants have done. It's going to be very difficult for us to choose a winner, I think, but I'm sure you'll all be able to put your token in one jar. So, well done to all the participants, the student supervisors, the AI advisors, the facilitators and the organisers in this inaugural. So participants, you'll be able to say you were involved in the very first one, the inaugural event, RMIT Redback Innovation Challenge. It was a great pleasure to experience all the presentations. And I know you have worked hard, and I suspect you've also had a lot of fun coming together and putting today's presentations together. Innovation is frequently described as turning knowledge into positive impact, and we will be working to move some of the opportunities you have presented today further down the path to impact. Some of you may be wondering Why did we call this the RMIT Redback Innovation Challenge? Well, the context is we wanted to differentiate this event from other external innovation events. The redback spider is our university mascot, and our sports teams are known as the Redbacks. I think we may be the only university in the world with a venomous spider as a mascot. That's something to be proud of. That differentiates us. That says there's a bit of bite in this university, there's a bit of potency about this university. The redback is predominantly black, and if it is large and actually has a red stripe, it is female. This symbolises or represents the value the university places on diversity and inclusion, one of our core values. The redback originated in southeastern Australia, but through ingeniously sneaking on board planes and ships, it is now global. The redback has gone global and apparently is thriving overseas. The redback thrives through an interconnected use of technology, design and enterprise. Some people call that a spider's web. In the interface, or web interconnectivity, RMIT prospers between technology, design and enterprise. It is our comparative advantage in the national and global innovation systems. We are a global university of technology, design and enterprise, and we saw that coming through today with the combination of technology, design and enterprise. We're similar to the redback, which is global with a comparative advantage based on technology, design and enterprise. One of Suri's team members also noticed that redbacks have 8 legs. Very bright, Suri's team. Spiders have 8 legs. And RMIT, coincidentally, has 8 enabling capability platforms. How apt. Makes it very easy to represent our 8 enabling capability platforms on the 8 legs of the redback spider. The fact that redbacks have 8 legs also makes them agile and effective. The RMIT ECPs, or enabling capability platforms, are our innovation legs for delivering value to the world beyond the academic world. In closing, I would like to reiterate my congratulations to the participants, the facilitators and organisers, and Maggie for doing a fantastic emceeing job. You've managed to keep us right on schedule, which is no mean feat. And please join me once again in thanking all the participants, the facilitators and the organisers.
Thank you, Callum. Thank you very much for supporting our activity today. And I would also like to extend my thanks to all the participants for your hard work, their innovation facilitators, Stephanie too, who did a wonderful job in putting this together. Our gratitude to the AI experts, Associate Professor John Tangaraja, Associate Professor Sebastian Sardina, and Dr. Jeffrey Chen for their facilitation during their sprints. And Dr. Lisa Deatherage from Media and Communication for your help as well. We're grateful to Professors Mingu and Professor Srimak for championing this activity since day one, and our organizing team for putting this wonderful event together. Thank you. My personal thanks to my manager, Damien Thomas, for his support. Yes. It was also wonderful that our Vice Chancellor could be here with us today, so that was really great. And finally, it was so great that all of you could come, and you've been a wonderful audience. I believe now it's almost morning tea time, but my colleague Riza there has cleverly set up 6 voting jars between you and the morning tea. So you're going to have to pass by the voting jars in order to get your tea and coffee. So all you need to do is, so you see the jars is labeled with the name of a team, and you need to put your tokens into the one you're voting for. And the People's Choice Awards will be announced today at 10:45 in the morning by Professor Sui Mak. So please join us now for our morning tea. Thank you.